Delaware Tech, Chemistry 100, Chemistry 110, Nomenclature of Simple Organic Molecules. We've already mentioned about the simple straight chain alkanes from 1 to 10 carbons, and we've given them names. They all end in ane. That's how you know they're alkanes. And you know there are 10 prefixes for 1 to 10 carbons, with methane being 1 carbon, so it's meth and ane, ethane being 2 carbons, propane being 3, etc., etc. Shown here is a 6-carbon structure, so you can write the 6 carbons just to help yourself. This is not the proper way to write it, but if you need this to help you understand how to view these structures, that would be fine. If you wanted to draw it as a skeletal drawing, you'll find that this becomes easier with practice, and this shows the same 6-carbon structure. So if we were to name this, we would use the prefix hex, meaning 6, and the suffix ane, meaning an alkane. In other words, it has only carbons and hydrogens and only single bonds between the carbons. So the answer to this would be hexane. That's what we would call it. And that's pretty simple. You've already learned that list, so there's not a lot new here. But what happens when you have something attached to your main chain? So shown here is another molecule. And now we have a main chain of 5 carbons with 1 carbon sticking out of the 2nd carbon. And obviously we have hydrogens on it, but we don't need to worry about the hydrogens when we're naming it. We first look for our main chain, and we have to number it. And we have 2 ways of numbering it. I could have numbered 1 through 5 left to right, or I could have numbered it 1 through 5 right to left. We always pick the way that makes our substituents, our side chains, our groups that are coming off of the main chain, have the lower numbers. If I numbered it the other way from 5 to 1, then what we'd find is that carbon that's sticking out of the main chain would be attached to carbon 4 instead of carbon 2. So you always want to number it so that your substituents have low number attachments. Shown below is the skeletal drawing. It has a 5-carbon main chain, and I'll circle that in case you're having a little trouble finding it. So we would circle the main chain and make a circle really tight around it to help you. And you see there's a single carbon side chain. Now, what I recommend whenever you draw these is put a little circle around your main chain and keep it tight. Don't include any other atoms besides main chain carbons, especially in the skeletal format. And then when you circle your substituents, notice there is a space here. I'm not circling the bond. I'm circling the atom that I assume is here at the end of the bond. And that lets me see pretty much the same thing as what I see here. A 5-carbon chain with a 1-carbon side chain. And we number it as we did before, 1 through 5, because that's our main chain of 5 carbons. So we know our main chain, which has a root of pent, is a pentane. It's some kind of a pentane. But what it has is a methyl group, a 1-carbon group, so that would be a methane if it was by itself, but since it's a substituent or a side chain or a group, we call it a methyl group or methyl substituent, methyl side chain. So, and it's sitting on the 2 carbons, so we would say we have a 2-methyl group. In other words, it's a methyl on the 2 carbon of the main chain pentane, and that's how we would name this compound. So that's pretty straightforward. So let's take a look at the actual set of rules. So you already know them intrinsically, but let's look at them in a little detail. So first you find the longest carbon chain, what we call the main chain. And it's not always easy to find this. Sometimes you have to hunt. They're not obvious. It's not always in a straight line. It's not always horizontal. It's not always where you think it is. So be careful. And if it has no double bonds or no triple bonds, we know it's an alkane, and therefore it will end in ane, A-N-E. The main chain can be numbered in either direction. You can start from one end to the other or vice versa, and you don't know, at least at first, until you find out where all your substituents are. So I recommend you circle your main chain first. And once you've circled your main chain, then circle all the substituents. So you're going to locate the substituents or the branches or the groups or whatever you want to call them that are attached to the main chain, but don't circle parts of the main chain. Keep your circles separate. That way you're not counting anything twice. And then use both your numbering systems and list all the positions that all your substituents are on. So if you had substituents on carbons 1 and 2, and another one on 2, and another one on 3, you would say 1, 2, 2, 3. But if you numbered it backwards, maybe it had 5 carbons, you wouldn't see the first substituent until carbon 3, and you'd have a substituent on carbon 3, and 2 on 4, and 1 on 5. So you'd have 2 different sets of numbers. And this may not make any sense until we look at an example, so don't get confused just yet. I'll show you, and it'll be much more obvious when we see pictures. So then you pick the set that has the lower set of numbers. And sometimes it's easy, and sometimes it's not so easy to decide that, but there's a really simple rule to figure that out once you know the numbers of where all the substituents are at. Then, once you've figured that out, start naming your substituents. If it's a carbon substituent, it ends in YL. Methyl, ethyl, propyl are all groups that are sticking out with 1, 2, or 3 carbons, respectively. If they're halogens, it would be fluoro, chloro, bromo, iodo. So you'd use that as the form of the name for your substituent. And then if you have more than one of the same substituent, if you have 2 of them, you would say dimethyl, for instance, or tribromo, or tetraethyl. So you use prefixes to say how many of each one. And it doesn't matter whether they're attached at the same place or attached at different place. You just count them all up. And if I have 5 methyl groups all over, I'm going to say it's pentamethyl for 5, and then worry about where they are right after that. So then every single substituent, every single one has to get a number. So if I have trimethyl, that means there were 3 methyls. I better have 3 numbers, 1 for each of them. Even if they're the same number, I better have 3 numbers. And then finally, once you've figured out the names of all the substituents and each set of numbers and the substituent names, then you just organize them in order of alphabetical order. And when you do alphabetical, don't count the di and tri and tetra, only go by the name, methyl, bromo, iodo. Just look at those words for alphabetical. Don't worry if dimethyl does not come before fluoro. Fluoro F is still before methyl M. And you'll see this as we go through an example. So let's go through a simple example first. Here's a condensed formula. We have 2 CH3 groups attached to a carbon, and then that's attached to another carbon, and another carbon, and another carbon, and that carbon has 2 more methyl groups attached to it at the end. So this is hard to see, so I highly recommend you rewrite this as a different version, preferably as a skeleton version, but if that's hard, you could write it as this other condensed form where you see the bonds in between, and now it becomes much more obvious where the main chain is. You might not necessarily see where the main chain is originally in the original version of this. In fact, you might have thought that one of those methyls was part of the main chain, and some people may have thought it wasn't part of the main chain. Well, one of them is, and one of them is not. So it can get confusing until you draw it. And if you want to draw it in terms of carbons attached to carbons, you can draw it this way to show the carbon part of the skeleton. But once you've figured out the formula, you're going to have to number it both ways. In this case, left to right and right to left. And then you look at it. Well, look at where the substituents are. We have a main chain that has 6 carbons. So we know the very end of this name is going to be hexane. We know that right away. It's something hexane. And we can write the ending of it right away. It's something blah, 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 hexane. And we know we have a methyl group here, and we have a methyl group here. And that methyl group is attached to, if we use the red numbering system, it's attached to the 2nd carbon and the 5th carbon. But interestingly enough, because this molecule is symmetrical, if we use the green numbering system, we have a methyl group attached to the 2 carbon and the 5 carbon, which is exactly the same. So it really doesn't matter which numbering system we use in this case. So we now know it's 6 carbons, so it's a hexane. We have 2 methyls, one's on the 2 position, one's on the 5 position, but there are 2 methyls, so we say dimethyl. It's 2 different methyls. It's not an ethyl. They are 2 separate 1-carbon units that just happen to be attached at different places. They could have both been attached to the 2-carbon. They could have both been attached to the 5-carbon. Or they could have been attached as they are to 2 different carbons. You would still say dimethyl because you have 2 of them. And then you give numbers for each one. So if I see a prefix di, I better see 2 numbers. If I see a prefix tri, I better see 3 numbers, etc. So now I just put it together. We've got all the pieces. 2,5-dimethyl-hexane, and that's how we would say it, 2,5-dimethyl-hexane. When we write it, if we're putting something, if we're trying to separate the numbers, we use a comma to separate number from number. We use a hyphen to separate number from letter, and you'll notice we don't separate letters from letters at all. We just cram it right up against each other. So keep that in mind when you're writing these formulas. You won't lose points for that, but just be aware that that's the standard format. A comma between the numbers, a hyphen between a number and a letter, and a no space at all between 2 letters. So here are 3 more simple examples. We have the first example with 2 carbons. Oh, we know it's an ethane. And we have a fluorine on it. And we can number this 1, 2, or we can number it 1, 2 this way. Don't number the fluorine, that's a substituent. You have a main chain with 2 carbons. We know it's an ethane. And the fluorine, we would go with the lower number always. So this would be 1-fluoroethane. The second one, we see we have a main chain with 3 carbons. So that's a propane. And it's attached to the middle carbon. So it really doesn't matter which way we number it. It's in the middle in either case. It's in the number 2 carbon. So we know this is 2-chloropropane. Remember, halogens end in O as a prefix. As a suffix, excuse me. So 2-chloropropane. Now let's look at the last one. Well, the last one, slightly tricky. Because you might say, oh, well, I've got a main chain here of 4, and I've got a methyl and a bromo on it, and that's pretty confusing. Well, if you can avoid doing that, you will always avoid doing that. Instead, you would pick the main chain, still has 4 carbons, that has separate bromine and methyl group attached to it in 2 different places. And this way, you can number it. If I numbered this 1, you'll notice our substituents would be at positions 3 and 4. When we look for positions, we're looking for where they're attached to, right? That methyl is attached to the 3 position, the bromine is to the 4. But the fact is, we have a better numbering system that could do this a little better. We could instead say the same main chain, number this carbon 1, this carbon 2, this one 3, and this one 4. Now we have the bromine right at carbon 1, and we have the methyl group right at carbon 2. So at this point, we know we have a 2-methyl group, and we have a 1-bromo group, and we know it's all attached to a 4-carbon chain. A 4-carbon chain is called a butane. Well, how do we know which one to put first? We know the butane will be last. That's going to be always last. The main chain is always the last thing you write. But how do you know which one to go with? Well, don't go by the numbers. The numbers don't tell you anything. You go by alphabetical order. Bromo comes before methyl. And as a result, our name would be 1-bromo because of the bromo, the B, 2-methyl because of the M, and then butane. And you'll notice the word methyl and butane are crammed right up against each other. And anytime we're separating a number from a letter, there's a hyphen, either before the number or after the number. And that's how you name that one. So that's pretty straightforward. So let's look at something a little more complicated. Here are a bunch of compounds. They have just carbons in them. They're pure hydrocarbon. They're all branched, They're all alkanes because they're nothing but carbon and hydrogen. They're all single bonds. It doesn't matter that they're branched. They're still alkanes. We would call these substituted alkanes. More commonly, you would call these branched alkanes. And let's look for the longest chain in each one. So if we looked at the first one, take a look. I'll give you a second. See if you can find the longest chain. Count how many carbons are your guess, and you can pause the video here. All right. So let's take a look at this first chain. Let's see if you got the same answer that I got. In red was my longest main chain. You'll notice this one has 1, 2, 3, 4, 5, 6, 7 carbons in it. So I know that at the end of this name, it's going to say heptane. 7 is hept. Ane is an alkane name. So we know the last thing we're going to write is heptane. And if you want, you can color code it with a pen like that, or you can take a pen and circle around the main chain tightly. And now you see I have 1 carbon here and I have 1 carbon here. 1 carbon units are methyl groups. So we have 2 methyl groups, so we know it's going to be dimethyl. And in fact, we know the words are going to run right up against each other, so it's dimethylheptane. But I haven't said what numbers they are. We have to number them. Well, it turns out this is a symmetrical molecule too. 1, 2, 3, 4, 5, 6, and 7. Our substituents are on number 3 and number 5, but if I numbered it the other way around, they would still be on 3 and 5. So we know our answer is 3, 5, 3, 5, hyphen dimethylheptane. And there's our numbers. I'll clear this out for you. And there's the name, 3, 5 dimethylheptane. Let's look at the one in the upper right-hand corner here. I'll give you a second to look for the longest main chain you can find. Okay, let's go on. Here's the chain I found, but it's not the only one. This one goes right across the top, but so I could have circled this as my longest chain, and you can see it has 1, 2, 3, 4, 5, 6, 7. We count from the end. Always remember to count from the end. There's a carbon there, right? 1, 2, 3, 4, 5, 6, 7. So this is another heptane. Now look at this. Some of you might have said, hey, I don't like that main chain. I picked a different main chain. I picked this one. I used these carbons, but here I went this way on my branch. Well, as it turns out, that's perfectly fine too. They're both 7 carbons. They both end up with exactly the same substituent. So it really won't matter which one you choose in this case. Sometimes it does. If you end up with a longer chain or a shorter chain, that tells you which one you should have used. Always go with the longer chain. So now we have to look for our substituents. Well, what's attached here? Well, we have a methyl group here. That's a 1 carbon. But over here, it's a 2 carbon. Now, you might be tempted to make 2 circles here, 1 for each carbon. Do not do that. Don't ever separate your substituent into individual pieces. What you want to do is circle the whole substituent. Now you'll notice my circles do not touch my main chain. I keep them separate so that now every carbon is accounted for with only 1 circle. One that's my main chain, my heptane. Again, we have a heptane. And we have 2 substituents, a methyl group, which is 1 carbon, and an ethyl group, which is 2 carbons. So how do we number this? Well, you'll notice it doesn't matter which way we number, we're still going to have the substituents attached to the 3rd carbon and the 5th carbon, but it'll be different depending on which way we do it. So this can be kind of tricky. This is beyond the rules that we would do. I would never give you one quite this tricky. But if you were to do it, you could number it that way. And we'll put the ethyl group on the lower one because it's lower alphabetically, and it also happens to be bigger, but it's lower alphabetically, so we'll number it that way with the lower one for the ethyl. If I numbered it the other way, the ethyl would be on number 5. I'm not going to test you on something that specific, but we can now see that we have an ethyl group attached to the 3 carbon of the main chain, and we have a methyl group attached to the 5 carbon of the main chain, and we order them, not by the number again, I know the number coincidentally matched, we order them by the fact that E comes before M. And if there were two ethyl groups, if I had another ethyl group sticking out here, instead I would have diethyl, and diethyl you still go by the E to alphabetize it, but now I need 2 numbers, and you'll notice both of these side chains are attached to the 3rd carbon, so I would write 3,3 diethyl if I had 2 ethyl groups on the same carbon. So let's look at the last one. I'll give you a minute, well, not quite a minute. You can freeze the tape and take a look to see if you can find the longest chain possible. All right. So did you find one that had a lot of carbons in it? Here we go. The one I found has 10 carbons in it. Go ahead, count for yourself to make sure you have 10. So we know this is some form of decane. Dec means 10, ane means alkane, and we have a lot of substituents on this. We have a methyl here, we have a methyl here, we have a methyl here, and we have 2 methyls here. Well, how do we number it? Well, we can number it 1, 2, 3, 4, 5, 6, 7, 8, 9, and if we did that, look where our methyls are. We have 5 methyls. So we know it's a pentamethyl name. It's not that we have 1 methyl group that's called a pentamethyl. We have 5 methyls. We call that pentamethyl. But that means we need 5 numbers. And if you look, always put them in order. So start with the 1st carbon and just look around until you see one. Oh, there's one at number 3. There's one at number 4. There's 2 at number 8. So what do? Well, turns out you write 8 twice. And then we have 1 at number 9. So we have 3, 4, 8, 8, 9 pentamethyl decane. But wait a second. Let's erase our notes here and start this again with a different numbering system. We numbered the other way. So this time I'll number it in red, and we'll start over here. We've got 1, 2, 3, 3, 4, 5, 6. That's the 7 carbon, the 8 carbon, the 9, and the 10. If we did this, we notice that our first methyl group is at number 2. Our next 2 methyl groups are both at number 3. 3, 3. Our next one is at number 7, and our last one is at number 8. Now, how do you decide between 3, 4, 8, 8, 9, and 2, 3, 3, 7, 8? Well, it's very interesting. If you put the numbers in order like I have, 3, 4, 8, 8, 9, they're all in numerical order, and 2, 3, 3, 7, 8, all you have to do is ask yourself, which of these numbers is smaller? 34,889 or 23,378? Whichever one's smaller, that's the one I keep. So we will get rid of all of this. It's not important anymore. And we don't use this numbering system. We use the red numbering system that we did later. So I'm going to erase all this. And we end up with this numbering system, and we end up assigning it the name 23378 pentamethyl decane. So now let's look at a real challenge. Here's a molecule. It has 2 fluorines on it. It has side chains on it. Take a look for the biggest main chain you can find. It might take you a few seconds. Well, here it is. And when you're looking for a main chain, just start from any end. You can start from an end here, or over here, and just travel along. And every time you come to a branch, ask yourself, okay, I come to this branch here, I'm traveling along this way. Which branch is longer, this branch or this branch? Well, I can see that this branch is longer, so that's the way I'll go. And then I come to this position, and I can see that this is short and this is longer, so I'll go that way. And that's how you look for your longest chains. So practice looking for that. So now we know our longest chain is a 1, 2, 3, 4, 5, 6, 7. I know there are a lot of heptanes here, but we now know this is a heptane of some sort. So we can write that right away. We know that's the last word in our name no matter what else happens. So now we have two possible ways of numbering it, from left to right and right to left. But look where the substituents are. So you have to ask yourself, where are the substituents? Well, in the left one, we have a methyl here, we have an ethyl here, we have a fluoro here, and a fluoro here. Be careful on those. Be careful what you're circling. Don't circle the bond, circle the substituent. In this case, I'm circling a bond because this substituent has two carbons, one here and one here. So I've got another substituent here, I've got one here, I've got one here. And if I number where they're attached on the main chain, this one has substituents, and it doesn't matter which one they are. 2, 2, 4, and 5 are where things are attached. But this one is 3, 4, 6, and 6 is where they're attached. Well, you always go with the lower number. 2245 is less than 3466. So now we know what numbering system to go with, and now we look at things. And you see our two fluoros, our difluoro, are both attached to carbons 2. So it's 2,2-difluoro. That's one set of substituents. Then you look at the next set. Well, we have an ethyl group attached to carbon 4, so that's 4-ethyl. And then the last one is this methyl group that's attached to the 5 position, so we have 5-methyl. So now we have all our pieces, and the only thing we know is this is dead last. We don't know the order yet. So what will be the order? Well, we look at the fluoro, we don't look at the D. Don't look at the D. We look at the fluoro, the E in ethyl, and the M in methyl, and we organize them alphabetically. And if we do that, we know heptane's last. Ethyl comes first with its number. Fluoro comes next, so it's 2,2-difluoro. F is after E, not the D. And methyl is last. And there's our name. And that is how you name a more complex substituted alkane. In this case, it is a branched one with fluorines on it, so we would call this a halo alkane because it has halogens on it. So now that you know how to name substituted alkanes based on the formula, let's go the other way around. And the other way around is much easier. So if we start with a name and we try to create a formula for a branched, possibly halo alkane, you'll see it works so much easier and it's much quicker. So let's start with one that looks really complicated, but I'll show you it's actually very simple. 1135 tetrabromo 2,5-diethyl 1-fluoro 3,6,6 trimethyl octane. This looks like it would be a nightmare, but I'm going to show you that this is actually a really easy problem if you're starting with the name. You start with the fact that it's an octane. You know it's an octane, so immediately draw your zigzag with 8 carbons. Count them to make sure you have 8 carbons. Start at one end, and you'll see that there are 8. Number it the way you want it. Left to right is usually easier for most people, but if you like right to left, that's fine. So now you have your numbering system, you have your main chain. Now you just look at each piece of the name. Start with the beginning. It doesn't matter what order you do it. 1135 tetrabromo. This tells you you have 4 bromos, and they are on carbons 1, 1, 3, and 5. So you literally just write lines from 1, 1, 3, and 5, and stick a bromine on each of them. Boom, you're done with that. The next group is 2,5-diethyl. That tells you you have 2 different ethyl groups. Remember, ethyls are 2 carbons, so I have 2 2-carbon groups sticking out of carbon 5 and carbon 2. Well, there's already something on 5, but there's room for another, so I might want to move my bromine over to the side a little bit to make room. but I just want to write an ethyl group. So that's going to be a 2-carbon branch off of each of those. And I'm done with the diethyl. So now I look at 1-fluoro. Well, I already have on the 1 carbon 2 bromines, but there's still room for 1 more substituent. So I'll just write my 1-bromo there. Now there's nothing more I can do with the 1 carbon. It's loaded up with 2 bromines, a fluorine, and the 1 carbon's attached to the 2 carbons. So all 4 bonds of the carbon at position 1 are already shown. Now we just look at the last part of it, 3,6,6 trimethyl. Well, that means we have 3 methyl groups and they're attached to carbon 3, to carbon 6, and another one on carbon 6. So let's rewrite it. We put our 3 bonds on 3, 6, and 6. And that's actually all you have to do because the bond has an end, which is a methyl group. So we're literally finished at this point. This is our answer. And you can see how fast it is if you're going from the formula to a name, as long as it's one of these simple substituted alkanes. So that's it.